Hi, let's talk about function. Function is a building block of program. Function is basically just a named sequence of statements that belong together. Sometimes people call function like a subprogram. Function help us organize programs into chunks that match how we think about the solution to the problem. For example, if you want to do home remodeling, what kind of step you're going to take, who are you going to call to, to do the step, and even if you're doing the step, you are basically still performing function. And function can be called or invoked from many other places in code. Um, do you remember you're familiar with the print and the input statement? And why do we use function? We use function because we can write once and we use many times. Here's the Python function definition. It's very straightforward. You have the keyword def to define the function, name of the function, privacy, an optional function parameter, and the statement that belong to the function. Notice that the function statements are indented. One of the key things about the function definition is note there's a colon at the end of the function definition header. We call this function header. The colon, as you will see in Python, it basically to denote like a start of a block of code. That is why the statement, the function body is indented. In Python, Python use indentation to denote like a block of code. Many other programming language using like for example curly braces, but Python use indentation. There is no curly braces in Python for block. The function parameter here is called formal parameter. So in the function definition, the parameters are called formal parameter, as opposed to when you invoke or call the function, when you will pass parameter to the function, those parameters are called argument or actual parameter. Here's an example of a function. Think about the function parameter like a data that function need to perform the task. As you recall, in like a college algebra, you have a function like f of x equal to x squared plus 2. The f of x, the f is a function and x is the function parameter. You will pass a parameter to the function in order for the function to evaluate some data. In this example, what is the formal parameter? Well, the formal parameter is the function parameter. So in this example, the function parameter is the name. What about the actual parameter? We call the actual parameter is a parameter that you pass when you're calling or invoking a function. In this case, the actual parameter is my name. And what is a global variable in this function? In the above function, the global variable is my name. Global variable is any variable that declare outside of function. So in this example, my underscore name is a global variable. Most functions require argument, value that control how the function does its job, and some functions do not return anything, like the greeting function you just saw, but most function does. We call the function a fruitful function, a function that returns a value. To return a value, we use a return statement to return a value in the function. For example, in this square function, the square function return the value y, which is the square of the input parameter. When calling a fruitful function, the function return value should be stored in the variable for later use. If you do not store the variable, the function return the data, and the data is not stored anywhere. It basically will be gone from the memory. Another thing about the fruitful function is don't display the result in the function. Return the data value. If you use, it's okay to use a print statement in the function, but it's not okay to use a print statement like it is returning value. You might think, hey, the program outputs the same thing. My function print the data, but the difference is what will happen if I want to call the function multiple times for different things, and I want to save the value for later use. If we print the statement, I will not be able to do that. So let me show you an example here with a pie chart. So let me comment out this part here. So actually, let me not comment now. In this example here, let me run this. You will see in my first example, I call the square and pass in 5, and I print nums underscore square. So let me just say num square is, so we can see the difference here. Let me rerun this. So the line 7 num square is 25, as you can see the output. And let me put this here. This is square bad. Again, I just want to show you the difference in the output. And the square bad, the square bad have a print statement. You print 25 here. Great, you have a right answer. But if I call square bad and assign the return value to num square, notice that when I print num square, it print none. If a function does not return anything, and you assign the return value to a variable, you will get none. Well, in the first example, I could have num2 square, maybe square of say 10, and I can say num square plus num2 square. You see, I save the function result so I can use it later. If you have print statement, you can never do that. Okay, this is again one of the problems that I have seen where students like to use a print statement in a function when it should be returning a data value. Scope of variables. When you declare a variable inside a function, that variable is what we call a local variable. And local variables cannot be accessed outside the function. That means when the function finished, all the local variables actually are wiped out from the memory. The formal parameter also act like a local variable. If a variable name is not found in the local scope, then the Python will look at the global variable or the global scope. Take a look at this program here. In this program here, I have a bad square. In the bad square, I pass it a formal parameter x, which is a local variable. I also have a local variable y, because I declare variable y inside this function here. So y is a local variable, x is a local variable, but power is a global variable, because when I look at the power, I did not find a local scope, and I will find that in the global scope. So power will be 2. So in this example, it would do 2, 10, x is a 10, So it would do 10 square. So the result in this case would be 100. Now look at what would be the proper use of a local variable. In this case, I have a function called power of. I have two parameters, x and p. And power equal p. This is a local variable power. This local variable power overshadows the global variable power. And it's very common to have a local variable have the same name as the global variable. And it is okay. For example, I can have a power of function with a power variable, local variable name, another function called square, which have another local variable named power. That is okay because local variable only contain inside a function. When you go out of function, these are like a different name. For example, I could have a student named Mike in this class, another student named Mike in another class. Those two Mike are, a different person, and I will not get confused who they are because I'm in different classes. Okay, so in this example, this is the better example to use a local variable in a program. Don't use global variable. And in this example, you will again it's the same thing. You would do 10 square or 100. Flow execution is the order in which statements are executed. When you have a function does not get executed until it is being called or invoked. So execution always begins at the first statement of the program. Statements are executed one at a time in order from top to bottom. And function definition do not alter the flow of execution. Again, functions are not executed until the function is being called. So what is the order execution for this program here? Well, line 1 to 3 is a definition of function. Function definition do not alter the flow of the program. Line 5 to 7 also is a definition of function. And notice that I can have a function calling another function. The square function called POW, the power function. It's very common for one function to call another function, which can call another function. Function can be changed. One way to see the order execution in a program is to use the PyCharm debugger. So here's my first quick introduction to Python debugger. Here is the program that you see in the slide. To use a PyCharm debugger, the first thing you need to do is put in a breakpoint. In this program, the first line you will execute will be line 11. Let me delete that line here. Will be line number 9, which is same as what you see at in my lecture slide. So I put a breakpoint by clicking on the line number here. As you can see, I just click. You see like a ball showing up here. And you right click. Instead of run execution, you run debug execution. And then the PyCharm debugger show up. You have two tabs here, debugger and console. The console is a console that we saw for like a prompting user input or output. And the debugger showing the variable data. Pay attention to this arrow here. Step over, step into my code, and step out of. So these are the main steps you're going to use. So if I do step into, notice that, pay close attention here. In my program here, do you see n colon 5? It's showing you the variable n have a value of 5. In the window down below here, which are kind of small, I'm sorry I cannot make them bigger for you. Is n is an integer 5 showing the window on the bottom. And if I go like, let me put a mouse here, step into my code, you can see that it called the square function, and in the square function, x have a value of 5. And notice that that is the order of execution. When I call square, that's when the square function get called. And then I step into, now the POW, the power function is called, and you can see B has a value of 5 and P has a value of 2. You can also see that in the variable window on the bottom here, bottom of the screen. And I go step into and do the calculation. Y 5 squared is 25, so Y is 25. Return Y and step into. So A is now 25 because you call the function POW and it return 25, and that 25 get assigned to the variable A, and return A, and result is 25, and then you print the result. And then if I go to console tab, you will see the 25 is printed here. The console tab for input and output, and the debugger tab showing the how the variable data evolve as a program run line by line. So for this program, it will run line number 9, 10, and then call the square 5, 6, and then you call the power function 1, 2, and 3, and then return the data 7, and then print 11. I mean print the result on line 11. So let's do a programming exercise here. Now that we know about program, write a function called f to c temp, which take one parameter temp. The f to c function converts the temperature in Fahrenheit to Celsius. Do you remember the Fahrenheit to Celsius program that we write in the previous lecture? The function return the Celsius temperature value. So let's go back to PyCharm and write this program here. This is the temperature program that we did in the past, and I want to make this as a function. A lot of time the process, the process in the IPO program is a function call, so I want to write a function like that. So let me create another Python file. Let's call it temp2. I'm going to write a function called f to c, which passing a temperature. This function is going to calculate Celsius temperature, and we call the Celsius temperature is my 5 divided by 9 times temp minus 32. Okay, so this is the function. Why do I use temp here instead of tempf that I used in my previous program? Well, again, keep in mind what variable holding what data. Temp in this case is the placeholder for the temperature value that I'm going to pass to this function. So I'm going to use a temp here. I do not have a tempf. So let's do an input. Again, let's do like a tempf equal to float input, enter temperature, for example, process. So for the process, I would call, so the temp c is calling f to c, and I will pass in 10f. 10f in this case is the actual parameter or the argument. Temp in this case is the formal parameter. Output, print, again, 10f is temp_c, and let's run this. Temperature 32 degree. 32 degree F is none. Uh-oh, what happened here? Why do I have none instead of a temperature value? What am I missing? Well, we call if you assign a variable to a function to a return value of a function, if you get none, that means the function does not return anything. So let's look at our function here. What am I missing? Notice that there's some squiggly line underneath the temp_c. If I put my cursor here, it will actually tell you some hint. And one of the hints is local variable temp_c value is not being used. I create a variable but not being used. I forgot to return the value. So let's run this again. 32 degree is 0 degrees Celsius. I can run this again. Say maybe in Florida, I guess there will be 80.5 degree. And 80.5 degree is 26.9 degrees in Celsius. So this is a tidbit about function. How to write function, that return data, and how to using the function parameter. Make sure you understand how to pass the parameter to function, the local variable within the function, and how to use it. This is very important. Function is the building block of a program. If you understand how to write function, you are on your way to be a good programmer. Thank you.